Hello, this is Jeff Beaudry. I'd like to introduce you to this video. This is a part of our one-day conference on student growth and educator effectiveness. And the title of the conference is Teacher Evaluation, Student Growth and Educator Effectiveness, Finding a Place at the Assessment Table. And it will be at the University of Southern Maine. The video that we're going to feature here is a presentation by James Gorman, who is a high school teacher from Northbridge High School in Massachusetts, entitled How Can Conceptual Change Be Visualized Using Concept Maps? The work that Jim has done also appears in an edited book by Lenny, Shedletsky, and myself, Jeff Beaudry, called Cases on Teaching Critical Thinking Through Visual Representation Strategies. As you listen to this video presentation, I want you to think about a few things that have to do with assessment and concept maps. First of all, there are discussions about different types of rubrics to assess semantics, topology, that is the shape of maps, for peer review, and for depth of learning, as well as a very in-depth concept map grading sheet. You'll see these and you'll start to see the purposes differ for each one. But I also want you to be aware of something that Jim made very clear. And I quote, "I don't tend to grade them," that is the maps, "because for the students it is an ongoing process and they can go back and revise them." I just want you to keep that in mind as you try to figure out how to balance formative and summative assessment. And finally, here are some questions to think about that have to do with the type of things that students are looking at in their maps. How did the mapping help students understand the topic of motion? Describe the use of maps as evidence in the progression of learning. You'll see that a number of maps were used for this one student, 5, in order to allow that student to show the progress or change in learning over time. Secondly, there are different types or different stages of map development that are discussed: spokes, chains, networks, and cycles. Has this helped you understand these different stages of map development? And finally, back to the point about balance. How did the instructor use maps with students for formative purposes and for grading and summative purposes? Recorded.
Hello, my name is James Gorman. I'm a teacher at Northbridge High School in Northbridge, Massachusetts. I thank Dr. Beaudry very much for inviting me to address this group. I'm going to be talking about visualizing student conceptual change using a specific tool called concept maps. You might or might not be familiar with what concept maps are, but this presentation is kind of it's in a concept map style. So we see at the top here, conceptual change, right? And we're going to be looking at it through concept maps, creating concept maps. A concept map is very simple, right? It lists out concepts like conceptual change and creating C-maps, but they're linked with a linking phrase. So it can actually be read as a true statement, a propositional phrase is what we call. So conceptual change is observed through creating concept maps. And a concept map just keeps adding progressively more and more concepts to answer a central focus question. In this case, how can conceptual change be visualized utilizing concept maps? In this program, CMap tools, I can link any type of digital media to it. So you'll see there's more concept maps under here. There's resources. There's images. So how I have my students, when we start a unit, we look at the beginning of the year, creating concept maps as a way of visualizing our personal understanding. Right? Each person in that room has a different idea or understanding of what a dog is. Some fear them, some love them, some find them benign, it's really related to our personal experiences. And so concept maps look at that and give the student the ability to express that along with the concept, so it can be read as a whole. Concept maps, what I love about them is it promotes higher ordered thinking. It forces the students to break down info into parts and find evidence to support those generalizations. So when they're talking about a dog or a cat or a ball falling, anything in the world, right? They can break it down into individual concepts, right? A ball. What is a ball, right? It might have colors. There's all sorts of things they can differentiate on. And then when they're looking at those concepts as a whole, right, they can maybe see connections between them. Okay? So fitting new insights into relationship with prior knowledge. So as we go through a unit in physics per se, we're learning about objects that fall. They might have some understanding of gravity, but maybe not a full, what we would consider of physics, a Newtonian understanding of what gravity is, right? 9.8 meters per second, 32 feet per second squared. Those numbers probably don't even occur to them, but as they go through, they can incorporate that information into what they already know and further elaborate. One thing I love to do with my students is having them use whiteboards, getting them together and using whiteboards, and I'll show an example here of a whiteboard. Let's see. Where it's a large 3x2 whiteboard that the groups get at the lab benches. It might be 2 to 3, maybe sometimes 4, depending on the size of the class. Students to a whiteboard. Sometimes we use sticky notes, sometimes not. And I just give them a list of the vocabulary. What are we starting off with? What are the main themes here, like vectors, quantities, scalars? And I ask them to order them, right? Make a bunch of true statements about those. So a quantity can be either a scalar or a vector. Not a bad statement. And then the students in groups work on taking and elaborating what a scalar is, right? Might have units and a magnitude. Well, how is that different from something like a vector, which would consist of a direction, units, and magnitude? And they progressively differentiate, and sometimes they find links between them, sometimes not. Let me see if I can bring up this second one. This group here, they organize it in sometimes different ways, sometimes similar ways. Sometimes they have other information that might not have been in other presentations. And as I go around, I'm looking at these. Okay? I'm looking at the structure of them. Okay? Is it branching out? So you can see there's a branch for scalar, there's a branch for vector that's much more differentiated than scalars, as I would expect, right? Because we're talking about vector components, adding them together, right? You can see here there's, they need to elaborate this concept about vector components. How are they using those mathematical equations? And so as I was going around, I might look at that and say, okay, you talk about vector components. What about vector components, right? How are you mathematically doing that? Just getting them to really interact with the material and debate each other, which happens quite often, especially when we get further on in the year. They'll really debate what a word might mean, One person sees it one way, one person sees a situation the other way, and they'll be arguing. And most times they might not be wrong at all. Both of them might actually be correct. It just depends how you look at it. So let's see here, right? When I'm going around also, I'm looking for misconceptions, right? Statements that might be false, right? They're really red glaring ones on there sometimes. And it gives me a chance to talk with the students, right? I don't have to ask 20 questions to find out what they understand. They're giving it to me, presented in a visual format, that I can then go in and almost poke their brain, needle them on points, where I can see, oh, they have a really nice, elaborate understanding of an object being thrown up in the air and what happens. But they might be missing one key element. Or more importantly, they might have a misconception. Like at the top, acceleration isn't 9.8, it's 0. And those will be all little things I can look at with concept maps. So how do I start them out with these concept maps? I usually start them with something called an expert, that's not the one I want, an expert concept map, which gives them an outline of what it looks like. So here's an example of their first map. This is like their pretest. Okay? And you can see here, I had motion, time, space, velocity, acceleration. These were all on there in rudimentary form like they are. And I had all these other, sorry about that, I had all these other concepts, one dimension, motion map, instantaneous, average, graph, position, free fall. They were on the side here called the parking lot. So I asked them, make some meaning of this. What do these terms mean to you? Can you relate them? And so this was his first try at it. His second go around is represented here, where the student goes on and he has a little bit more understanding. You can see he's added some concepts in here, like vector and scalar. He's also started to make it his own. I tell them, make it your own. If we're talking about motion, what do you like about motion? This student happened to particularly like snowboarding. In the third iteration, you can now see that tangle, that mess that existed before, is now starting to be teased out here. You can see velocity, acceleration, displacement on this side, motion maps, time, space. They're all kind of disconnected. And what we'll see the students start doing is now connecting those various domains. Okay? So you have displacement and velocity still here. But now it's starting to connect with time through rates over to the motion maps and actually looking at those objects. Okay? And then as we go, oh, I didn't point out. As we're going through, in CMAP tools, I can leave little notes for the students. And so that's what these are, little notes to ask them questions or make suggestions. You can really do anything you'd like. And this is his, I think, close to his final version of what we ended up with, which wasn't pretty bad, right? It's a pretty good representation of what he knows, right? And each person is going to have a different structure, and that's okay. My job as the teacher is to look at it and evaluate. What does his structure overall look like? So talking about assessment for a little bit, right? How do I assess these? I already kind of told you some of the qualitative methods I use. Getting a general impression. Are they stuck? Are they not stuck? How does it look? And along with looking at what they're actually saying, those propositional phrases, I'm also looking at morphology or the topology of the map. And to do that, right, here represents a spoke structure, right? Is a simplest structure. There's some central concept and things are linked off of it. There's no differentiation or cross-linking between any of the concepts. And the student will tend to elaborate this, right? So as a teacher wants them, they'll put it in a nice orderly sequence sometimes. A chain of events might happen, right? It's really a goal-oriented or a procedural type knowledge. I do this, I do that, I do this, What we say typically it's held by strategically successful students. What we really want to push those students to is this network version, what you just saw in that second to the last map, right? You can see there's not only branches, but those branches have connections between them. And that's the key. That's where meaning really starts to be created. The concepts aren't seen anymore as separate entities that have no connection, right? They exist in two separate domains. There now is some connection between them and has been made visible for the student. And this really reflects their understanding. And you can see it change over time as you're looking at the maps. Another well-known structure is called a cyclical structure, where you'll have those quite often in there, which is also a well-ordered structure, usually expressing some functional relationship, maybe between like a motion, position, time, and velocity, right? Be an example of one. So those are quick assessments you can do just to get glimpses into how that student is viewing the material. You can also get quantitative on it, and there's a whole bunch of rubrics that have been developed over the years. There's semantics, just looking at what the student says, right? What those propositional phrases say. There's ones that look at topology, the structure of the map. Are there any cycles? All that sort of stuff. There's peer review you could do, right? One reviewing another article, another concept map. Depth of learning. I like this one. This one actually compares a pre and post test. Okay? So this one, it breaks it down into deep, surface, or no learning. And it's comparing two concept maps, one in the beginning and one along the process, right? And it's looking at the concepts. Was there any concepts added, right? How are the linking phrases that put everything together? Are they valid? Are they true statements? Do they explain and give you some insight? Is there evidence provided about those connections? And then generally the overall structure. Is it a network-like structure, or is it chain, right? Or is it just like a spoke structure? All of those can be put together into a rubric, and there's no standard way right now of doing it. There's all different versions. Myself, I don't tend to grade them, just because for the students, it's always an ongoing process. They can go back and revise them. So what I do, I'm always needling the students. Oh, did you consider this? Oh, did you consider that? Oh, what about this part here? I kind of developed this sheet based on a couple of the others. Linking phrase concept, are they true propositions? Right? Are there any misconceptions in there? That can be great. And you could emphasize them however you'd like. This is just one version. Are there any dynamic propositions? Right? So just not straight definitional, but get into how do these two really relate? Right? A cat is black. Well, that's nice, but it doesn't have to be black. Right? Get really into the meat of it. And quantity and quality of the crosslinks. Are they making those network structures, in other words? Are they linking two or three branches together of knowledge so that it becomes one network? And 6, are there presence of cycles? Sometimes it might be, sometimes it might not be. Functional type relationships, right? And a lot of times that's where the creativity comes, when the students can visualize what they see, what they know. They can sometimes pick out, oh, wait a minute, Mr. Gorman, this concept here and that concept, they go together. And they get rather excited when I say, oh, how? And I keep egging them on, and then they make a new connection on their own. Right? That's what they find most exciting. I hope you got an understanding, a little bit more understanding of how concept maps can be used to visualize student understanding and their change over a period of time. I thank you very much for your time, and I wish you a wonderful conference.